My name is Jeb Benson. I'm with NIST, just down the road here in Boulder, National Institute of Standards and Technology. Great spot. I'm specifically with a group called Public Safety Communications Research. And what I'm going to do today is just kind of talk about not so much what we've done, but what we'd like to engage with this community to do. Okay? So like I said, I'll kind of just go through a few basics, and then we'll just set the stage for later on this week. A couple questions to start off. Have any of you ever worked on an SDR for first responders? That's what I thought. A couple hands, right? Have you heard of FirstNet? How many have heard of FirstNet? A few hands, not so much. And would you be interested in working on a grant or competing for a prize to create a prototype SDR for public safety? Any interest there? Is that it, really? All right, so my job is to convince you to get engaged here. Hopefully turn the tables. So a little bit of background. I'm actually been shocked and amazed that today we've heard the term P25. We heard about emergency response. Those aren't things we typically hear at these kind of conferences a lot of times. But the landscape today for public safety radio communications is a very diverse one, to say the least. There's a whole slew of standards, some open, some closed. These range from P25, the DMR, NextN, Tetra, and then of course your old analog FM, and a bunch of proprietary ones in between. So there's a lot of groups involved: standards bodies, TIA, APCO, NextN, ETSI, et cetera, et cetera. Even as recent as yesterday, there's a good reminder of how difficult this can be for first responders. In 9/11, when they released the 9/11 Commission report, one of the key findings was that interoperability was a severe problem, and it led to deaths. The firefighters couldn't speak to one another in the different buildings to tell them to evacuate. There's case after case study about how the problems of interoperability is presented for first responders. Katrina is another classically cited one. So that's been kind of in discussion for a while. And then in 2012, Congress decided to act on it, largely due to the interests of public safety who were really pushing this agenda. But basically, later on in this bill called the Middle Class Tax Relief and Job Creation Act of 2012, they provide funding and the wherewithal for the U.S. to stand up the National Public Safety Broadband Network. That's what provided the authority for FirstNet. And so, along with that mandate, they said that network, so this was going to be a 10 megahertz of spectrum that they allocated in the 700 megahertz band, upper 700 megahertz band. 758 and 788 are your two markers there. That they mandated that it would be LTE, so based on an open standard. So that was the creation of FirstNet. In addition, in that act, they also allocated $300 million of research and development funds to NIST and PSCR specifically to help accelerate some of the critical technologies for public safety to migrate onto something like FirstNet, and also other other technologies that they will be able to leverage now, having access to a broadband network, right? So things like location-based services, analytics, some new enhanced user interfaces, okay? These were areas that we worked with our stakeholders starting in 2013 to define, what are some priorities of interest for you guys, for us to invest in over the next 7 years. Our funding for this R&D ends in 2022, okay? So based on that, look at LBS, analytics, and UI. In addition, that legislation also mandated that we in PSCR focus on mission-critical voice, which we'll talk about here, and LMR to LTE networking. So again, LMR being all the other systems that are out there today, land mobile radio. How do those two systems kind of interact side by side? Because you can't expect that overnight everything's just going to go onto FirstNet, right? So this is really a major transformational moment for public safety right now, a very exciting time. They don't have access to broadband networks like we do, or if they do, oftentimes it's their own cell phone. They're using their own subscription. Increasingly, you're starting to see them use more enterprise level access to LTE, but in those networks, they often don't have any kind of priority, right? They're just like any other user. So when something bad happens, and they really need the network, well, guess what? They're in the queue just like everybody else in the network. So something that FirstNet provides is actually that priority, and even the ability to preempt, to kick people off the network, all right, to get access to the network. and a quality of service that they need as well for their communications. So these are kind of our 5 main technology areas in NIST. I'm going to pull my phone out just so I have keep an eye on the time here. And then kind of across those, sort of cross-cutting, interoperability, security, and that user experience, right? We're very focused on the user at NIST. So what is mission-critical voice, right? That's a term that public safety throws around all the time, but may not be very familiar to this community. So we wanted to know what it really meant to public safety, so we brought in a bunch of our key stakeholders and talked about it, had a roundtable. One of the great things about public safety, and the reason why I think you should get interested in working with public safety, this is a phenomenal user group, okay? I came from the defense and IC sort of background, and I know how difficult it can be to kind of target your end user, right? A lot of times you got these E1s through E3s who are really using your product, and by the time you just get to know them and know what their requirements are, well, they're gone. So you end up with a bunch of real detailed requirements from your system engineers or whatever. It's very hard to get access to that end user. That was always, I was a government employee in the DoD. It was tough for me, okay? With public safety, you've got access to these guys. There's 5 million of them around the country, okay? 60,000 different organizations, which also is coincidentally one of the reasons why the disparity of the communications, right? That's 60,000 different groups that are making their own contract decisions, okay? So for first responders, the key elements of mission critical voice, from a user perspective, push to talk, walkie-talkie kind of stuff. You can instantly, sequentially transmit messages, one-to-one or one-to-many, okay? Talker ID, they like to know who is talking. They need a little, some data on their screen there. Emergency alerting, this is something I wasn't familiar with, but they have a button on their radio that they can click when they are in imminent peril or emergency, okay? They click that, it sends a special message out, they get priority on their network, and everybody knows they're in trouble. Audio quality, very important to public safety. These guys are not operating in pristine environments where you can just use any kind of vocoder and expect high quality audio. Very key. And sometimes that, sometimes you want to sort of mute, cancel out all that noise. Sometimes that noise has some actual ambient information in it, right? Bullet shots, or you hear other car collisions going on in the background, things like that. Violence, fights. So it's a delicate balance, to say the least. Group communications, they have to be able to talk groups, right? When they broadcast, it's going to the proper group. It might be going across groups, et cetera, et cetera. And then direct mode, and this is what we're going to focus on a little more here as we drill down. This is the ability for them to operate independent of being on the network. All right, so they can actually, they go into direct mode for a couple of different reasons. Some of this is called simplex mode in this world. But they can either do it because, say you're a bunch of firefighters going into a basement of a building and the network coverage is kind of unreliable. So they want to just know that they've got control. They're not dealing with spotty coverage. They also do it for operational reasons, just to simplify things. Make sure that nobody else can interfere with what they're doing. They've got their own dedicated channel. And the commander makes sure that his guys and gals are focused on their group and not some other groups trying to scan around. So it's done for different reasons, but it's a critical, and if they're just flat out of range. Okay? So this is a key capability for public safety, absolutely critical. They're not going to migrate to using voice on something like FirstNet until that capability is there. So when we met with these, our first responders and talked about some of the KPIs and benchmarks they're interested in, these are just a sample of some things that they're really interested in. I'm just providing them because, again, it's a different community than many of you are used to dealing with, but some things that you're kind of familiar with, interference, capacity might be a little different one. The failure rate, when they key up, how many times does it take them to actually get access to the channel? Latency is a big deal, right? When they hit that button, it's got to be like under 300 milliseconds or so that they've got a channel if it's open, okay? And hang time, that's something where, if a guy's accidentally keyed the mic, or if there's too long between a connection and a talk group, sort of that talk group times out. They do trunking a lot of times in the land mobile radio system. So when a talk group has got access to a shared channel, they've got it as long as they're active. But say that they're talking, and then there's a delay of like 3 seconds. Well, that's holding up. That's tying up the channel. That's tying up a slot. So that hang time says let's cut them off and make the channel available to somebody else. So another kind of neat parameter. And then intelligibility, which is about actually being able to hear what's being said, not the actual audio quality. There's a distinction in this community between audio quality and intelligibility. So bottom line, a bunch of different parameters are important to these folks. Really important focus on direct mode and things like emergency alerting, the first responders. So in order to implement something like mission critical voice in LTE, a whole bunch of standards work needed to be done in 3GPP. So I'm going to go through a kind of what I'd call like a technology stack of what was done in 3GPP to start down this road. The first thing they did, or one of the things they did, was create this document called the Mission Critical Push to Talk over LTE. This is kind of a high layer, application layer sort of specification that lays out the requirements of what a mission critical push to talk system will look like for first responders. In there, well, it really does mess up your PowerPoints, OpenOffice. Maybe one of the platinum sponsors could sponsor like an Office 365 license or something for next year. You know, things like Talker ID, emergency alerting, those are really feature-oriented kinds of things. Then you've got some your vocoders in there, AMR wideband, and this new one, EVS SWV. So adaptive multi-rate wideband is kind of the mandatory vocoder. You'll see that being used in LTE already for things like VoLTE. And then actually before they even released MCPTT over LTE, they implemented a couple, well actually let me follow these two threads here. So group communication, we talked about that one-to-many sort of capability. In order to enable that, they had to create this group communication system enablers, or the GCSE LTE, and then also decide that they were going to leverage a broadcast bearer. Right? So if you've heard of MBMS or EMBMS, that's been around since release 9, but not really heavily used in LTE. It is a broadcast, multicast physical bearer, okay? Think like stadium events, things like that, where you want to get some information out to a bunch of users at once without taking up a whole bunch of resource blocks in an LTE channel. So, and then also, in order to do direct mode, they had to create this whole new set of services called proximity services. And that created something called a D2D bearer, that's again, we're going to kind of drill down, focus in this area a little more. But all of these things can kind of tie into just a public safety UI. So imagine an application server somewhere back off of the network. That's your mission critical push to talk piece, and that could connect to any kind of UI on the front end. All right, so I think I'll just do like 2 more slides, and then we'll kind of call it good and then set the stage for the next talk on Wednesday. But basically, what I'd like you guys to do, you know, a lot of you are on travel, you're sitting around your hotel, looking for things to do. Maybe check into proximity services, okay, and D2D, device-to-device communications. See what you find out there that you think there's some interest in getting involved in that space. But this proximity services created basically 4 new features: direct discovery, EPC level discovery, direct communications, and then a Wi-Fi sort of link. D2D, direct communications, is the one that's really important to us at the moment. And you'll see why when we continue on Wednesday. But basically, they created this new link between UEs, right, which in LTE and 3GPP world, the mobiles are called the UEs. This PC5 interface, so this is the ability for these 2 mobiles to talk to each other without actually going through the network. They can also talk to each other when it's network assisted as well, where the network tells them when to talk and how to talk, but the ability to be totally isolated from the network is required as well. So something kind of cool to look at, we'll talk about later. And this whole idea of proximity, this is not like location. This is basically you're in some sort of range, you're adjacent to, and that is that's all relative to the application, right? Proximity for one application can mean something totally different than another application. So in doing that, where it gets real interesting from a radio perspective too, is that all of this device-to-device communication is going to be going over what's called the side link, right? You've got your downlink, you've got your uplink. Well, here's the side link. The side link is going to be on the same frequencies as the uplink. So this creates a whole lot of questions and opportunities for investigation. The UEs now really, they need to add another receiver, right, to the system on a chip, or however they're implementing the devices. So I think with that, let's stop there. What I'm going to talk about Wednesday is a little more like how we get from here to actually being able to prototype something. There is no capability for D2D on the market, period, end of story. So what I'm going to talk to you guys about is how do we get capability in our hands that we can test and evaluate, so we can kind of work through some of the bugs, find the gaps, understand how the side link works in an uplink channel before we see products, if we ever see products rolling onto the market, okay? So that's where I'm going to leave off. Any questions?
All right. Michael, can you get to Michelle?
Hi, one of the things that I'd like to ask you about is the codec situation with the things that you're describing, because it's a mess.
What do you mean with the EVS versus the...
Well,
AMR?
with all the different concatenations and trying to make everything work together, and LTE
Right, so-
over or LMR over LTE.
right.
And is there any
So 3G
pathfinding that
yep.
you've done here?
Yes, well, so we have a group, so PSCR is actually a joint group between NIST and NTIA. And at NTIA, which is also down the street here, there's an excellent group that focuses a lot on audio quality. So they do a lot of work on the audio codecs. 3GPP is actually working on a specification right now for the LMR to LTE internetworking piece. So there's going to be some kind of transcoding that occurs there. And that happens now, too. There is already some pieces in place. But a way to standardize that, make one plugin for all these different LMR type systems to access LTE, that's kind of in progress. And that will be one of our key areas for research. But we're letting that unfold a little bit in the specifications and standards body so we start really focusing on it. Thanks.
So hopefully this is real fast. You mentioned device-to-device, really important. Nobody's really working on this. When the 5G standard started to become, or not standard, the standardization of 5G started to come out, there was a huge push initially for M2M/D2D, whichever you wanted to call it. That has seemed to completely drop off of the conversation in recent, maybe 6 to 12 months that I've been following it. So do you have any insight there?
So that's going to be a big focus on Wednesday, right? And so just the tagline for now. So D2D changed the way 3GPP thought about radios. Before it was just, this whole push to talk, it was a walkie-talkie thing. They wanted nothing to do with that. They wanted to be on network, control everything, right? Then they started looking at this D2D capability, which was pushed by first responders. This was not something 3GPP brought up. And they started thinking, wow, this is actually pretty interesting. Then you've got NB-IoT, all this IoT stuff going on, a machine-to-machine. You're like, how do we make money off of this, right? That's where it really, because it's all a bunch of vendors working on these standards together. Well, for a moment, D2D had they had their shining moment in the sun. But now, 5G, IoT, and V2X have taken everybody's attention away from D2D. Okay, so part of what I want to talk about next Wednesday is how we kind of work within that space, use our funding to get folks like you engaged to get these capabilities moving forward in the interim, because we know we're going to need them. So yeah, great question, great segue.
Question?
Yeah, you may have already touched on this in your previous answer, or you're going to touch it on Wednesday, but for D2D, did the 3GPP, are they proposing some type of different PHY? Are they proposing something where you have a bunch of SC, FDMAs sort of talk to each other? What's the details behind that?
Right, so you do need another, we'll talk about how it is half duplex, which was great when we heard the $300, not the RTL, but the HackRF, device. That would work. There are some new physical channels defined, and new protocols, new message, new system information blocks, things like that. Yeah, and we'll talk a little more about that. There's some really, really cool, challenging problems for you guys in terms of synchronization and the way resource selection works in LTE, if you're familiar with that. So I think some really fun problems to study. Does that answer your question? I'll follow up. Okay.
All right. Let's thank our speaker. Thank you, Jeb.
Thanks.